Okay. Wait a minute. I have to ask tech department, please. Ekran paylaşımını yapamıyor. Amiru, ilk konuşmacı. Şu. Tekrar deniz. Tamam. Amiru, please
Yeah.
try again.
Okay. Yeah. Okay. Can you see my screen?
Yes, we can.
Okay. Good afternoon, everyone. My name is Amir Abdul Karim. I am an MSc student of Electrical Engineering from Üsküdar University. I'm going to present this paper titled An Ultra-Low Voltage Hybrid Converter for Energy Harvesting Application. The aim of this study is to to utilize two different sources of energy that can be harvested from human body or human body activities. Like human body movement can generate mechanical energy and can be turned into electrical energy. And then human body heat also can be harvested to produce electrical energy. There are two devices used in harvesting this energy, the piezoelectric generator and the thermoelectric generator. The piezoelectric generator is used to harvest human mechanical body movement to electrical energy. And we use an AC-DC converter to convert this mechanical energy to electrical energy. Generally, the piezoelectric generator used to produce an AC voltage. So we have to use an AC-DC converter to convert it into DC voltage. Then the thermoelectric generator also is used to harvest human body heat in form of DC voltage. And we use a DC-DC converter to convert it into a higher DC voltage, because generally these voltages from these devices are in order of millivolts. So for we to get a reasonable amount of voltage to power some biomedical equipments, we have to raise them to at least 3 or 5 volts, depending on which type of device we are going to power. So this converter aims at harnessing these two different sources of energy. This is the structure, the block diagram of the converter. Its aim is to harness these two different sources of energy to produce a DC voltage that can be used to power some biomedical equipments like ECG or some monitoring equipment like wearable devices. So this is the structure. And then the circuit, the circuit is divided into two. From this block diagram, we can see that this is the AC-DC circuit and this is the DC-DC circuit. So the AC-DC part utilizes a coupled inductor. This is the piezoelectric generator. This is the internal capacitance of the piezoelectric generator. It is coupled with a coupled inductor which raises the voltage to about 2 volt, and the 2 volts at the exit of this transformer or coupled inductor is passed into a voltage Doppler rectifier, and then the voltage is smoothened by a diode capacitor filter. Then from this voltage Doppler rectifier, there is the DC-DC also. This part, the DC-DC part, feed the voltage Doppler rectifier its input also. So this is the process of the charging of the first capacitor of the voltage Doppler rectifier. This secondary part of the coupled inductor and this capacitor C1 act as a resonance section that will help to make a kind of oscillation that will raise the voltage. Then furthermore, this is the second part, because the AC voltage produce voltage from a positive quadrant and the negative quadrant. So the oscillation, or let's say, the oscillation produces voltage both in the negative quadrant and the positive quadrant. So in the first quadrant, the C1 is charged, and the second quadrant, C2 is charged. This will make the output voltage to remain stable. So then this is the DC-DC part also. The DC-DC part takes an input from the thermoelectric generator, and this is a coupled inductor with a center tap. We generally call it center tap transformer. So it converts the small, generally from 20 millivolts to 100 millivolts, and it converts it to a higher millivolt from this secondary part. The primary part of this center tap transformer is connected to 2 JFETs, because we use JFETs in this process. Someone is talking. Okay, let me continue. The JFETs J1 and J2 are used in this process because they can turn on with very minimal voltages. So we use JFETs in this process instead of MOSFETs. And they work in 50% duty cycle. So when this one is on, the other one is off. And they make some oscillations. And this resistor acts out as like a form of output resistance. When we put a higher resistance, it makes the circuit to build a high resonance, like a high resonance voltage. And we use these 2 capacitors because this is called a Royer oscillator, and generally Royer oscillator produce square waves. We use these capacitors to make it an oscillating wave, like an AC wave, because of their gradual charging and discharging process. So the output of this Royer oscillator is connected to the input of the voltage Doppler rectifier to add off the voltages of the 2 parts, the AC-DC part and the DC-DC part. And this is a graph of how the Royer oscillators start oscillating. From the beginning, the 2 JFETs are off, and after some milliseconds, they start resonating, and after some time they reach a steady state of their oscillation. So this is the complete circuit diagram of the hybrid converter. This is the DC-DC part. This is the AC-DC part, and they are connected through this path. We use a small rectifier because this produce a high AC voltage, and we can not feed the same AC voltage to this voltage Doppler rectifier, because when we feed it with the same type of oscillation that comes out from this part, it becomes down, like the output voltage become very small. But if we add a small rectifier along the way, it reduces the stress in the circuit, and it builds a bigger output voltage. I think that's basically how the hybrid converter works. This is like the 100 millivolt AC, the 100 millivolt DC, the AC and DC, and this is the output voltage. This is the output of the transformer or coupled inductor from the AC part, and this red line is the output voltage using about 10 kilo ohm output resistance. Okay, this 5.1 volts is produced from a 5 kilo ohm output resistance, and this is the contribution of each voltage source when they are the primary. When the AC voltage is the primary, it contributes about 98% of the total circuit contribution. And when the DC voltage is the primary voltage, it produces about 35% of the total output voltage. This is the comparison of the tables of some state-of-the-art converters produced from 2023 to 2024. And all of them use two DC voltage sources, but our own produce utilizes both AC and DC voltage sources to convert to a DC output. And the conclusion is that this is a novel idea, and this is the beginning of the research. So there are a lot of work to do about this concept. For further research, design of the control circuit of the converter will be done, and also the redesign of the process using CMOS nanometer process, and then elimination of the magnetic components, that is the coupled inductor, also is supposed to be done to reduce the electromagnetic to improve electromagnetic compatibility of the circuit. I think that's all for now.
Amiru, thank you. Thank you for your contribution.
Okay, thank you, sir.
Does anyone any question or comments? Okay. Where are you from?
I'm from Nigeria.
Nigeria.
Yeah,
How can I say by using your local language, good job?
good job. You say yayi kyau.
Yayi kyau.
Yayi kyau.
Yayi kyau.
Yeah.
Thank you. Thank
Okay,
you.
thank you, sir. You are welcome, sir.
You're welcome too. The next speaker, second speaker is here, Alcanza. I suppose. Yes.
Evet, buradayım.
Okay, can I remove the stop the sharing?
Yes, please.
Okay.
Alcanza, please introduce you and begin.
Merhaba, benim adım Alhansa Osman Muhammed Abdullah. I'm from Sudan.
Hoş geldin.
Hoş buldum. Ee,
Ekran paylaşımı yapabilir misin?
Efendim?
Ekran paylaşımı yapabilir misin?
Aha.
Please share your screen. Yes, we can see. Görebiliriz.
Belli oldu mu şimdi?
Evet.
My presentation's name, my abstract name, the performance of power electronic interface in smart grid implementations. The first, we have introduction, modernization of global power grid. What is the modernization of global power grid? Increased energy demand and need for stable, efficient, and resistance power supply. Okay, role of power electronics technology, enhancing smart energy areas, generation, distribution, transmission, demand, response. Şimdi, the basic functions of importance for power electronics, it's power conversion, AC to DC, DC to DC to AC, AC to AC, and so DC to DC. Power conditioning to remove distortion, harmonic, volts, dips, and over voltage. High speed and or frequent control of electrical parameters such as currents, voltage, impedance, and phase angle. Okay, the benefits of power electronics, it's we have more benefits of power electronics. I'll summarize for some points like high power density power supplies, improved efficiency of up to 99% in power conversion, noise sensitive applications such as in medical devices are also transition to switching power supplies because of the efficiency and reliability. Power can be made available in the desired from and level as per specifications. Increased clean power generation using power electronics interfaces to connect the source to grid, and so wireless power transfer, integration of renewable energy sources, enhanced grid reliance and efficiency. What is the advance? What is the advantage of power electronics? It's some key advantage of using power electronics include high efficiency power processing close to ideal 100% compact size and lightweight modular design, flexible and digitally controlled output. Energy efficiency and conservation. Power electronic system enable the efficient conversion, regulation, and control of electrical energy, contributing the energy conservation efforts and reducing energy waste. Becky, what are the applications of power electronics converters? It's like these converters are used to regulate and shape an electrical signal in the required form. Among these converters, AC-DC, it's more used from another converters, AC-DC converters, commonly known as rectifiers, are used extensively in renewable energy systems such as grid-connected DC microgrids, grid-connected solar photovoltaic energy conversion systems, and etc. What is the impact on microgrid and distributed generation systems? Key functions in place enabled by power electronics. For sure, power factor correction, static variation compensation, electric demand management, integrated power networks, improve grid reliance, encourage renewable energy integration, ensure equipment stability and quality, maintain and correct power supply. The critical functions during transition from grid connected to isolate mode, connect renewable energy sources, storage devices, and loads, convert DC power to AC, maintaining grid compliance, enable bidirectional power flow, improve grid reliability, power electronics model for distributed systems, inverters and rectifiers, circle from microgrid operation. The simulation tool, we used a PSSpice or cut PSSpice for high relation in grid activity and transient dynamics test example and stability. Demonstration test example using PSSpice models highlight scalability to support sophisticated nonlinear mode. Becky, what is the PSSpice? PSSpice is a powerful generation proposed analog and mixed mode circuit simulation that is used to verify circuit designs and to predict the circuit behavior. Its name implied from simulation program for integrated circuit emphasis. PSSpice is PC version of SPICE, a student version with limited TBK completes, comes with version textbooks. The ORCAD student edition is called PSSpice AD Lite. The benefits of escapable circuit mode, we have mainly two benefits: applications and future integration. Application, it's large-scale transient stability analysis, grid level planning, and so future integration re-enables power electronics, storage, distributed generation, and microgrids. In the end, power electronics are vital and modernizing microgrids and distributed generation, and so scalable models ensure stability and efficiency in future power systems. Thank you very much.
Thank you. Thank you for your contribution.
Thank you very much.
I think, in my opinion, it's very useful paper for some journal. Yes?
Yeah.
I hope so. Does anyone have any question? Okay.
Thank
Okay.
you. Thank you very much.
Your certificate will be sent by an email.
Okay. Thank you.
You're welcome. You're
Thank you
welcome.
very much. Thank you. Have a good job.
Thank you. The next speaker is Mahamat. Mahamat is here. Are you here?
Yes, I'm here. Hello, sir.
Okay. Okay. Let's begin. Alcanza, please turn off your share screen.
I cannot share my
Yes.
presentation.
Alcanza, please. Okay. Now you can
Is
share.
it good? Okay.
Yes.
So
Now is good.
I'm sharing now. Ekran paylaş.
Yes.
Bas. Basıyorum da ama yani hiçbir şey çıkmıyor hocam.
Ee,
Acaba
yeşil
bir
butonu mu
yerde mi sıkıntı
kullanıyorsun?
var?
You have to use green button. And
Yeah, now is good. Paylaş.
yes.
Nasıl?
Yes, that's okay. We can see now.
Is it good now, right?
It is good.
Okay. Good afternoon, sir. My name is Muhammad Shetima. I am from Chad.
Got
And my presentation will be held on design and analysis of single phase LLC converter. So the goal of this work is to detailedly analyze and examine the working principle of the LLC resonance converter, and by LLC we can say that we use the L. The first L is for inductor. The second L is for inductor 2, and then the last C is for capacitor. So the content will be start with the system presentation. Here is the system architecture. First of all, we have our DC supply, which we use in the laboratory, and then we have the MOSFET part, which are the silicon carbide MOSFET, very useful in power electronics, and then it has a very high very high of frequency. And here we have our main resonance circuit, and after this we have our rectifier circuit, and then to get a very nice DC voltage, we use a capacitor as a filter, and then here we have the load. So here we have the section that we use to design our response circuit. The LNC resonant DC converter is constructed with the resonant capacitor, which we can see it here, and then we have our resonant inductor, which is noted by LR, and here we have our high frequency transformer, and then here we have our full bridge diode, and then here we have our load. The load here is fully DC. We can see it here when we give to our 4 MOSFET a PWM voltage. We can see that we get an AC voltage here, and then when the AC voltage passes through the CR and the LR, we get IM, which is the magnetizing current, and then we have the LR, which is the current through our resonant and inductor. And then when it passes through the transformer, we get a very high voltage peak to peak, which is DC. Then when we go through the diode, we get the same DC, but it has some how we can say some very bad voltage with some harmonic peaks, and then to make it a full DC, we can just use the Cout capacitor for filter, and then we can use it for the load. This is the equivalent circuit in S domain that we use to find our resonance capacitor, and then our resonance and inductor, and our magnetism inductor also. So here we have the mathematical expression for all of these 4 parameters, which are here. Here is the M, which is stated for the quality factor, and then we have the Q. So this is the first resonant frequency. We know that for an NLC converters, we can choose between the minimum resonant frequency to the maximum resonant frequency. So FR1 is for minimum resonance frequency, and then FR2 is for the maximum resonant frequency. So this is also a mathematical expression. And then here we have the relation between the output voltage to the input voltage, and then we can make the Q and then the N to have what voltage we want. So here we we have the three operation region for the LLC resonance converter. Here is the capacitive region, and then here also is the resistive region. For us, we need to work on this region, which is the inductive region. We can see the resonant current here at
İnternet bağlantısı kopmuş gibi gözüküyor. Biraz bekleyelim isterseniz. Please wait a minute. I think there's a... Okay.
Sorry. Yeah.
Muhammad,
Yes.
are you here?
Yes, sir.
Yes.
And then,
Please continue.
okay, thank you. And then below the resonance frequency.
Please share again. Please share again. Screen share, please.
Oh, okay. Share. Okay.
And you have 7 minutes.
Okay, I will handle it.
Okay.
Inshallah. So below the resonance frequency, we are here in the first region, which is the resistive region. We can see that the resonance current leg, like here, the resonance current lead the magnetizing current, but here the resonance current leg the magnetizing region, which is the resistive region. And then here we have the capacitive region, which is above the resonance frequency. Here we have a few, or we can say lower conduction losses. And then here also we have lower conduction losses. And then to reduce this switching losses, that's why we use the full bridge during the second high side of the transformer. And then here is our full circuit, which is simulated using the PSIM, or we can say PSIM, which is the simulation environment used in power electronics. And then our parameters are this. We have 270 watt, and then our output voltage is 380, and then our input voltage is within the range of 50 to 61, and then as a resonance frequency we use 66 kilohertz. This is our transformer. I use the eagle to make my cat. This is the quorum protection circuit, and then this is my full bridge MOSFET, as you can see it here, and then this is my microcontroller, which has a high resolution timer, HR timers, and then this is my get high side, and here is my get low side, and to control my card, I use the STM, as you all know. And then here is my code on the STM. We don't have so much time. That's why I just need to show you my work. This is for my experimental results, and then I use all this kind of things that you can see it here. And then this is my test. I test it, and then I get this wave form. Here we can see that we are in the inductive region, which has 0 voltage losses. And then here also, when we are at resonance frequency, and then here I wrote a PI code to see my voltage, both in with multimeter, and then with the STM QPID, and then here also, and at the end we have the power graph of the output versus the efficiency, and then here also we make some measurement to compare. You can see all here. We have the V-in, V-out, and duty, and conclusion. So this work focuses on the analysis of the LSC power resonance converter, and then as you can see, by using the SiC silicon carbide MOSFET, we can get a output voltage with fewer conduction losses, and then at the high resonance frequencies. So here are my references, as you can see it, and then thank you for your attention.
Thank you for contribution.
You are welcome.
Does anyone any question or comments? Not okay.
I have no.
You are from Chad, yes?
Yes, I am from Chad, and then I work in Techno Park.
Okay, I see.
Yeah. So thank you very much.
This is very detailed presentation.
Yeah.
In my opinion, you will send us for
Okay, sir. I will be in touch with you, and then I will send all. So without wasting time, I can leave to our guests. Thank you very much, sir. Without wasting time, I will leave to our guests to make their
Thank
also.
you. Yes,
Okay, thank you very, very much.
you're welcome. Muwafaq, are you here?
Yes, yes. Sure. I am here.
Okay.
Sessiz.
Muhammad. Muwafaq.
Hocam ben sessiz aldım.
Tamam.
Yes.
Yes. Please, you are the next speaker. You can begin.
Yes.
Are you here? Okay, tamam.
Hello.
We can see you. Please,
Hello, my name
do you hear
Muwaffaq
me?
Abdullah Saleh.
Welcome. You can use share screen, the green button. Yes. That's okay. We can
You-
see your presentation.
Are you share with you?
Yes, yes, yes. We can see.
Hello.
We can hear you and we can see your presentation. Please begin.
Paper
Start.
title using BCI technique to move the head and neck, advanced robotic design to improve human-machine communication experimentally and theoretically. By Muwaffaq Abdullah Saleh, Nahrain University, Department of Mechanical Engineering, Baghdad, Iraq, and Muhammad Abdul Sattar, Department of Mechanical Engineering, Nahrain University, Baghdad, Iraq. The outline of my presentation, including an introduction of dynamic robotic head using BCI technique to rehabilitation, theoretical work, experimental work, EEG signal acquisition device, results of theoretical, results of experimental, comparison of results. Introduction of to dynamic robotic head rehabilitation is the process of restoring person's health patient of ALS patient or DHS patient or Parkinson and others, or ability to lead a normal life through training and treatment, as this picture, or the head neck brace. Sorry, robotic technology have helped in the field rehabilitation in the past 2 decades because it provides assistance to patient to perform complex functional tasks. Head and neck movement play a role in promoting vision, eating, and drinking. Using BCI technique to rehabilitation, brain-computer interface technology lets patient interface with the device such as a head-neck brace by brain waves and perform order movement without muscle movement. As this picture contain signal acquisition and to signal processing to device command, such as head neck brace or wheelchair or robotic hand. Theoretical work of this research of my research. The main idea of mechanism being used, 3 RRS means 3 revolute link and revolute link and spherical arms connected between the base fixed ground and the end effector. This is end effector. After analyzing proposed mechanism and solving this equation to determine the value of the maximum rotation angles for the main movement of the head neck brace, theoretical. Experimental work. After choosing the shape of the mechanism, used the 3 RRS and designing all the required parts in the SolidWorks program. Then all bases were manufacturing using 3D printing technology using a printer of the type Creality Ender 3 Pro and the Cura program. And the BLI biomaterial using due to the specification approved to the shape of the proposed mechanism within required movement, such as durability and strength in proportion to the flexibility of the required movement, and low a cost, and also reducing manufacturing time. This is picture of the experimental head neck brace. My research concluding a head collar and a triangle head and connection arms and servo motor, 3 servo motors and shoulders, 2 shoulders, backrest, power supply, Arduino circuit with the sensors. EEG signal acquisition device. The EEG signal acquisition system in the research device proposed open PCI comprises 60 channels electrode with their 2 reference electrode, thus 16 channel board, Cyton and Daisy on the head. It is taken from the drawing on this picture. On the 10 to 20 EEG electrode placement system, using they use the open PCI device as shown in figures. Results of theoretical. My research, the value of the maximum angles of movement were calculated using theoretical method, shown result in the table using the equation. Movement rotation to right, maximum angle 70 degree. Rotation to left, maximum angle negative 70 angles. Up extension of the head 55 degree. Down flexion negative 55 degree. Lateral bending, this is movement, lateral bending right and lateral bending left is the 38 degree, positive and negative. Results of experimental. After the real-time reading of the brain signal via the brain-computer interface to the neck brace. Experimentally, the maximum angles braces movement were obtained using gyroscope sensors. This is but on the right, on the top of the head, to specify the angles. The maximum rotation angles experimentally, rotation to right plus minus 55 degree, up and down of the head, plus minus 42 degree, lateral bending to right or lateral bending to left, plus minus 29 degree. This is a maximum angle, rotation angle experimentally. Comparison of the results. By comparison, the theoretical results and the practical results, the maximum angles of the rotation, the main movement of six movement to the support neck brace as drawn in the figure. The green line, it is the experimental angle, and the red line is the theoretical angle, is the rotation movement. Comparison of the angles of the rotation movement, and the comparison results by comparing results and practical results. The maximum angle extension and the flexion is the up and down between theoretical and experimental is the figures. Also the green line is the experimental angle, and the theoretical angle is the red line. This is a comparison between angles of extension and flexion of this movement to head neck brace. Also comparison by the lateral bending, right lateral or left lateral bending of the movement is the figure. The theoretical angle is the red line, such as up to angle. Theoretical is 40 is the 38 degree, and experimental is the 29 angle. Thank you for listening.
Thank you for your presentation. It's a good one. And in my opinion, it's very exciting subject. Thank you.
Thank you.
Does anyone have any question or comments?
Question?
There's not. Okay. We will send your certificate by an email. Thank you for your contribution.
Thank you. Thank you. Thank you.
The next speaker is Uzayir Ahmet. Are you here?
Are you live?
You can.
Thank you.
Okay. Uzayir Ahmet, are you here? Please, your microphone is closed. Turn on your microphone.
Hello.
Hello, welcome.
Thank you very much. My name is Uzair Ahmed Nasiri, and I'm from Afghanistan. Today, currently I'm doing my master degree at Karadeniz Technical University, computer engineering. So today I'm going to explain the classification of cardiac arrhythmias, or we can say the heart abnormalities using CNN LSTM network and white future. The agenda for today, first of all, we have to know what is cardiac arrhythmias. Then we have to know what's 12-lead ECG signals. Then we have a brief description of the dataset which we have used. After that, we have the techniques that we use for pre-processing and the architecture of our model. Then result and conclusions. First of all, cardiac arrhythmias, or in a simple language, we can say heart abnormalities. It refers to a group of irregular heart rhythms. It causes serious health problems like heart failure, stroke, and even death. According to World Wide Organization in 2019, 32% of deaths are responsible by the heart abnormalities and causing about 17.9 million deaths. So diagnosing and treatments arrhythmia is challenging because the structure is very complex. That's why it's essential to classify abnormalities accurately for proper treatment. The complexity of heart abnormalities requires advanced diagnostic tools and methods for accurate identification and classification. So now we are jumping to know 12-lead ECG. 12-lead ECG is a very important way to check the heart problems. 12-lead ECG recordings are acquired from 12 points of our body, or we can say from hearts. We can achieve it from the heart's electrical signal from multiple viewpoints. Interpretation of ECG recordings by experienced medical professional is very time consuming. So that's why advances it need automatic classifications. And in recent years, advances in deep learning have increased the number of classifiers for 12-lead ECGs. Several algorithms have been created to accurately identify the heart problems, but the problem is that these studies haven't compared with a wide range of heart abnormalities, or we can say at very good data sets. They usually focus on a few types of, such as atrial fibrillations or at a specific like ST changes. So to address these problems, the China Physiological Signal Challenge in 2018 dataset provides a more comprehensive database. In this slide, we can see the 12 leads in 10 seconds from lead 1 up to lead 12, and the corresponding names that are technically, it's like medical names that in here you can see them. So then we have to discuss about the dataset which we are using. The CPSC 2018 encourages open source research methods, allowing access to data and algorithms for analyzing physiological signals. This helps in identifying and predicting cardiovascular disease. The CSP 2018 goal is to detect any irregularities in rhythms or morphology of 12-lead ECGs. This challenge contributes to a more comprehensive database, including 1 normal and 8 abnormal types, which we can see the 8 abnormals names like atrial fibrillations, and then like this 8 one is the segment elevated, and the others are here you can see with their abbreviation. So in here we can see a normal and abnormal signals. Like for example, this is the lead 2 signal, this is the normal, and this is the abnormal signal, and we can see the difference that it have kind of difference. And lead 7 normal and lead 7 abnormal signals in here we can see it. So, and this is also 1-bit signal, and the signals have this kind of structure, and the name for every points are shown in here, like P, Q, R, S, and T points. So this one shows the normal rhythm, and this one show a atrial fibrillation diagnosis. That mainly we can see that it have difference in P and in T points from the normal one. So the ECG, the CPSC 2018 ECG recordings from 11 hospitals were used in a challenge. The dataset was divided into training and test set with a 1713. The training set comprised 6,877 12-lead recordings, while the test sets comprise only 2,954. Recording lengths range from 6 seconds to 60 seconds with a sampling rate of 500 Hz. The training set include 3,107 female and 3,699 male recordings, while the test sets have including 1,416 female and 1,568 male recordings. ECG signals were divided into 9 types, as I said before. The test set is not publicly available and remains private for scoring purpose. That this was for challenge. So in this table, we can see the brief summary of the all data that we have. Then we had for classification, we had some pre-processing techniques. First of all, we downsampled the all signals to 100 hits because to reduce the computational time, and also to reduce the computational time, and we use a FIR bandpass filter with the bandwidth of 3 to 45 hits to remove the noise that the signals have, and also recordings normalized between -1 to 1, and we choose a random fixed wait window for a fixed input to our model with 16 seconds. And the signals that are less than 16 seconds, we pad it with 0. Our model comprises from 2 main. One is static feature extractions, and the other is deep side. The static feature extraction, first of all, we get first lead of ECG signals from all recordings. For feature extractions, how we extract the features, as we know that features have PQRST waves. So these features include amplitudes and duration of PQRST and T waves per bit. Summary statistics calculated like mean, median, and standard deviation for amplitude and duration. Additional calculations like PR, QS, RT interval times, and P-wave energy. And totally, we have extracted 140 static features. So it's a lot, and we don't need it, all of them, because all of them are not as important. So we used random forest algorithm to rank features, and we selected top 16 features, which is ranked by random forest algorithm. Then final model includes 18 fixed features, 16 top features plus gender and age. These are the static features. And in here, we can see the all static feature that we extracted from the signals. This is a 1-bit signals that is like S wave amplitude that show the S wave amplitude. And in this way, all features are extracted here and ranked, and we get only top 16 one. Then our CNN LSA model, first of all, our model have a CNN, some CNN layers, and then it have a LSM layer. CNN layers extracts spatial information and patterns indicating heart abnormalities from 12-lead ECG signals. LSTM layers capture temporal and long-term dependencies in ECG signals. A fully connected layer produces deep features. Static and deep features combined and then feed to a final fully connected layer for prediction classes. In here, we have the setting for our conventional layer and also the high parameters that we can see that our conventional layers, we have 4 conventional layers, the input size 12 because we have 12 lead, and output size is 128, kernel size 10, strike 2, and padding 1. In this way, finally, we have 256 output size and yet feed it to the LSTM. And as we can see, the high parameters, ECG window size, as I said, that it is 1600 because it is 60 seconds, and we set the frequency rate 100 hertz, so it's like 1600 hertz one input, but it's like when we have 12 right, it also multiplied to 12. In this way, we can see the frequency rate, batch size, static features, and all of them. So in here, this is our model architecture. We have raw ECG signals, then it feeds it to CNN LSTM, global max pooling, and fully connected layer. In here, we have 64 deep features and 18 wide features, and we concatenate all of them and feed it to a fully connected layer and CAD diagnosis or 9 classes that we have. The result, we used 10-fold cross-validation. The batch size selected was 128. Number of epoch 13, because after 13, it doesn't have an increase, so we stopped 13. Means of 10-fold cross-validation result in AURC of 0.9358 for validation and 0.9324 for the test set. And in this results, we can see the all faults that what is the result which I got. Like for the test set 0, we get like this one, and some of them have very like 0.927 So the means are in here, as I discussed before. And the conclusions, this study demonstrated how combining deep learning methods like the CNN method with wide ECG features can accurately classify arrhythmias. The approach improves patient care and outcomes by addressing the complexity of arrhythmia diagnosis. Using static and automatically learning features allow the model to spot differences in the data better, improving diagnostic capabilities. The successful use of deep learning in cardiac diagnosis show how artificial intelligence can transform healthcare. These study findings will help develop more advanced diagnostic tools for diagnosing and treating arrhythmias, benefiting patients and healthcare providers. And this is the references that I use. Thank you very much.
Thank you. Thank you very much. Thank you for your contribution. I think very useful. That is very useful presentation. Does anyone, any questions? Okay. Okay. We will send your certificate by an email. Okay.
Okay. I also written the whole documentation. If you want, I can send the paper as well.
Oh, thank you. Thank you very much.
Okay. So I will send the paper by tonight, inshallah.
It's not necessary. Tomorrow is okay. Next week is okay
because
for
I
us.
have because I have already written, so that's why.
You are very quick. Thank you very much.
Welcome.
You're welcome too. The next speaker is Aryan. Aryan, do you hear me? Are you here?
Hello.
Hello, welcome.
Thank you.
Mm,
Can you hear me?
yes, I can hear you. Please, if you can, turn on your camera.
My internet is a little weak right now, so I might not be able to turn that on right now.
Okay, no problem. Let's
Thank
begin.
you.
You can share your presentation. You can.
The CSP 2018 goal is to detect any irregularities in rhythms or morphology of 12-lead ECGs. This challenge contributes to a more comprehensive database, including one normal
Right.
series.
Okay.
Can I start?
Yes, you can start.
Is my screen visible?
Yes, we can see your presentation and we can hear you.
Perfect. So my name is Aryan Rajvanshi, and I'm a grade 11 student from India. My paper today is based on the early detection of crop diseases using CNN classification. So before delving into the paper, why is this problem so important? Why is this so pertinent right now? So in India, agriculture contributes to over 18% of the GDP and has over 150 million workers hired in the workforce. So it's obviously very significant. It's obviously very significant in the country. But in spite of this, the backbone, which are the farmers, are being extremely underrepresented and are extremely face poverty year round. The main problem over here is the crop losses, which take place due to crop diseases, which is over 30 to 35% per year. And these crop losses lead to them having lower incomes, which in turn lead to high debts and over 10,000 suicides per year. So after conducting several field interviews and actually gathering the primary data, I learned that this can be solved very easily using these image analysis algorithms, especially CNN in our case. So I went about the entire problem with a very simple 8-step solution, where the first was, of course, understanding and choosing our initial test disease, which was apple black rot. So I was able to procure a data set of over 20,000 images using, of course, online data sets like Kaggle, chemical and fertilizer companies, and again, more field visits, which was followed by choosing which image analysis algorithm would give the best results for this use case. So after testing and comparing 3 key algorithms, which in this case were k nearest neighbors, support vector machines, and of course our main algorithm, convolutional neural networks, CNNs gave much higher accuracy because of their multi-class analysis features and the ability to run several iterations of the same model. This was followed by uploading all the data procured into the model and actually loading and testing so this is again some code which was used to run the CNN. And we, in this case, ran 7 epochs and 6 epochs. And this was necessary because at the 4th and 6th epoch, the data didn't increase more beyond, and it stabilized after epoch number 4. So we got a validation data accuracy of over 98% and a training accuracy of around, again, 98%, which was extremely effective when actually employed in the farms. So the same was repeated with 3 other diseases, one being grape black rot, corn common rust, and strawberry leaf scorch, each having similar data sets of around 20,000 pictures. So these algorithms were paired with drone technology, where drones were used to capture pictures of the infected crops in the fields, which were then imported into my laptop and run through the algorithm to help us identify which location and which crops had the disease and which did not. And this actually helped over 80 farmers in villages throughout India and is currently being employed in many more. To talk about the program ethics, and our program has it follows the basic program ethics that every AI model should, be it fairness, be it reliability, security, inclusivity, transparency, and accountability. Again, these are a couple of references which are leveraged throughout the abstract and the paper. And that's it. Thank you. I'd now like to open the stage for questions.
I'm sorry, my internet connection is not good. I think now is okay. Aryan, your presentation is finished?
Oh, yeah, just finished.
Okay. Does anyone have any question? Okay. Thank you. Thank you for your presentation. We will send your
Thank you.
certificate by an email.
Sure, thank you.
Thank you very much. The next speaker is Alif Diambu. Alif, are you here? Alif?
Yes, I'm here.
Yeah. You're welcome. Please share your screen and begin your presentation.
1 second. I'm trying to find the screen. Just give me a second. Give me a second.
Okay, no problem. We have enough time. Gitti.
Can you see my screen now?
Yes, we can see your presentation and we
Thank
can
you.
hear you. Please begin.
So, in this presentation, I'm going to talk about the sustainable use of food waste from the traditional dishes of the Democratic Republic of the Congo of biocomposite reinforcement. It's quite a theoretical work, but you will see together how this is important for that community or even for the scientific community, since there's been a lot of gaps concerning our traditional dish waste that have not been until now capitalized or used for better, for the best of a human being. So this work has been performed or done by myself and my professor, supervisor, Professor Dr. Mehmetchevik. As introduction, combining natural fibers with polymers, which is actually the aim of biocomposite, are really becoming important nowadays because we have a lot of waste out there and we really need ways to get the best of it and to actually, instead of just burning them or harming the nature, to give it a better use. So if we go back in countries like ours, by the way, I'm from Congo, most especially dishes waste are just thrown or maybe burnt, and we may only find like less than 10% of dishes that are actually reused somehow or in some way. So food waste is a pressing global challenge today with a significant environmental impact. According to the FAO, roughly 1/3 of all food produced in West, and this decomposing food is landfill generates methane, a potent greenhouse gas with 25 times the warming power of carbon dioxide. Reducing food waste presents a critical opportunity to combat climate change. And our country is a country of brimming with culinary traditions for hearty stews, and so we have a lot of meals. From those meals, it's actually a good idea to see how to capitalize all the waste from those dishes, like from the cassava, because cassava is one of the most used meal of Congo, and then we have some vegetables, fruits, and so on. So these are kind of gold mines for biocomposite development. So let's go and take a glimpse into the variety of food waste generated in DRC. So we start with starchy roots. We have a couple, including cassava, as I just mentioned. With cassava, we have the bagasse fibrous residue and its peels. And these are just thrown away. And if we go, we take a look and into yam peels and even sweet potato, we can find that the peels of this food or these plants are waste and they are not capitalized. Beside that, if we go and see fruits like mango pits, orange peels, and even pineapple cores, often discarded after consumption, these actually hold potential for biocomposite reinforcement. These are just a few examples. We have a lot of them, so it won't take enough time to, we don't have enough time to show them all here. And if we go for vegetables as well, one of the most consumed vegetables are plantains. And those plantains, if you take the peels, you dry them, they really represent a big potential for biocomposites. It's an out layer of the fruit, of this fruit, a common waste product. And we have like okras, we have green beans and leafy greens. All those waste can be utilized for biocomposite reinforcement. Beside that, we have like groundnut shells. Groundnut shells are out there, and plenty of them in ways they can actually be used for further or better utilizations. And by these products, we can take in peanuts, and we can take more than that, like Bambara groundnut. Actually, Bambara comes from abroad, like from Eastern African countries, but we have quite amount in our country too. So these are kind of ways we can capitalize. And one of the most existing waste that I remember are those coming from palm trees. So palm kernel shells are a big representation of waste in my country or our countries. So these products are really a good source of for biocomposite reinforcement that we can capitalize. The same thing goes with maize cobs. So the list is very long, and most of these waste I've just cited are not have some of them have been studied, but some of them still represent gaps in the literature. So there are a lot to do in this field by just seeing what we're eating and what we're lefting over, and then utilizing it to benefit to the humanity. So current food waste management practice in my country, in the DRC, are limited and often inefficient. So we have some problems. We have like limited collection and processing techniques. So formal waste collection systems are often absent in rural areas and even some urban centers. This leads to improper disposal and food waste, such as open dumping and burning, which contributes to air and soil pollution. And unfortunately, there's a lack of infrastructure, which actually is not enough, so limited for composting or other organic waste processing technologies, hinders the efficient conversion of food waste into valuable resources. And we have informal recycling. So informal recycling practices are actually one of the reasons why we just can't take better use or maybe use those wastes. So while offering some resource recovery, they're actually not enough. So we need like kind of optimization for food waste that is yet to come. So we still have a lot to do, but assessing this is important so that we know where we are and what we have to do, how we can really take advantage from our environment. These limitations I just highlighted, they actually show the need for improved infrastructure. And not only infrastructure, people need to be educated. You know, for instance, if when I was doing this research, I found out that there was almost nothing existing toward improving ways people handle food waste. So there is actually a lack of knowledge. Almost nobody is working on biocomposites, let's say, or maybe a way for a better disposal or recycling these waste from food. And potentially, we have a problem with innovation. So countries like ours, we don't have like a TÜBİTAK, we don't have like a cost gap to support some great project young people might have. So unfortunately, we still have a way to go, but still, we need to know that we have that, and they are sources to be capitalized. So challenges: transforming DRC's food waste into biocomposite holds promise, but hurdles remain, unfortunately. So collecting sufficient waste, especially in rural areas, requires improved logistics. What is actually now limited. So we need like a good collaboration to overcoming these challenges and unlocking the potential of this sustainable solution. Yet we have opportunities and kind of solution because we already know the problem. So if you know the problem, you actually halfway to finding the solution to the problem. So DRC as a country of ours, food waste offers a big chance for biocomposite production. But still we have these challenges to overcome. Overcoming these challenges, especially in rural areas with less than 10% of collection rates, actually really requires collaboration. Collaboration between governors, the population, and the people who understand how important this is. So researchers, like people working in the academical environment, local communities, and policymakers can work together to develop efficient collection systems, establishing good processing facilities, and create quality control standards. This collaborative approach can transform waste into a valuable resource in the DRC. As a conclusion, we know how rich our dishes can be, but now the target is to see how to get a better use of it. So we need like a sustainable material development. With the sustainable material development, biocompost derived from food waste reduce reliance on virgin resources and all greenhouse gas emissions compared to traditional materials. Effective waste management is needed too. Why? Because we need to diverting food waste from landfills into biocomposite production, lessen environment impact, and promote a more circular economy. So when we go for the very last point, we see that we really need resource recovery. So food waste, once considered a burden, becomes a valuable resource. Since people don't actually consider it as a burden, they just see it normal if they stay there in the environment. As long as people are not educated enough, they don't know how that can actually be changed to real income like giving people jobs and maybe creating new jobs, and then making the environment better than it is. That those wastes will probably, or of course, create new materials or maybe new appliance that people can be used in daily lives, and potentially boosting local economy. So by harnessing food waste for biocomposite development, the DRC can embrace a more sustainable future, tackling waste management challenge while creating eco-friendly materials. The list is long. So for future works, we really think that we need an optimizing processing techniques. We need material characterization. As we already started with our PhD works, we are finding a lot of gaps and trying to close those gaps and giving as much as information as we can to the literature and improve this. So life cycle assessment, construction materials can be really improved from this kind of future works, and packaging materials. We know now almost every big companies working in this field are like targeting biodegradable materials, and we also know there is a big chance to get those materials while using biodegradable fillers like food waste. So then agricultural applications can be really improved or can be brought to a better or higher standard by somehow giving these solutions to the current problem we are having. These are some references we use in this study, and I thank you for your time. If you have any question, I'm ready to get it.
Thank you. Thank you for your presentation. I suppose it's a very good presentation. Does anyone, any question for Alif? There is not. Okay, the last, Alif, thank you again.
Thank you, sir.
The next speaker is Can Çivi. Can, are you here? Beni duyabiliyor musun?
Duyabiliyorum. I'm here. Thank you very much. Can you hear me?
You're welcome. Yes,
Okay.
we can hear you. Let's
Okay.
begin. You can share your screen.
Okay. Sorry, my bad internet connection. I can.
Me too.
I can share my screen. Can you see it?
Görebiliyoruz. We can see.
Okay, thank you very much. My presentation about life and reliability examination of internal and external gear contact mechanisms. Gear mechanisms are indispensable mechanisms used in many machines as power and motion transmission elements. What's expected from gear mechanisms is that they can achieve a high cycle rate in small area and function for a long time. In this study, safety, life, and reliability comparisons of gear mechanisms in terms of root and flank safety in internal and external gear contact were carried out. A modular calculation tool for machine element design is named KISSOT, is used for the study. The program is available for evaluating internal and external gear. Within the scope of this study, calculations were made within the ISO standards. Let's begin. Gear mechanisms work with conjugate motion and enable the torque to be increased with this conjugate moment of the gear systems, as you know. Among the power and motion transmission mechanisms, there are most used mechanisms due to their high efficiency and ability to use reliability, all power and speed values. Internal and external gears can be used in gear mechanisms. The use of internal gears is especially common in planetary gear systems, also harmonical systems, called gear tooth geometry of external and internal involute gears can be described by the same equations, except the following rule. The number of teeth is given positive in external gears and negative in internal gears. However, studies show that different stress values occur in internal and external gear systems. And the most common types of damage is in gear applications are fractures at the base of the teeth, and the other is wear on the side surfaces. For this reason, the strength control of gears is examined from two aspects in this study. One of these tooth root strength and the other of this heart stress. Repetitive stress causes a material to fail at stress lower than its yield point. Fatigue is the term used to describe this kind of material failure. Cracks that occur gradually and often thin and small are what led to the failure. Generally speaking, fatigue is a significant issue that impacts any moving or structural part. Wöhler is credited as being the first to do methodical experiment research on fatigue strength. Wöhler identified a material property in this experiment that is now known as a fatigue limit. One of the most hazardous types of gear failure is caused by tooth root bending fatigue. Consequently, a crucial component of gear design is defining gear bending fatigue strength. In actually, a correct estimation of the component SN curve is necessary in order to evaluate a gear component. To prevent the fatigue failure caused by the bending of the tooth root, designers utilize multiple standardization calculation techniques such as ISO, AGMA, and the others. They state that the both root state stress is compared to the limit value for the desired life in order to evaluate a gear pair. In the study, a comparison of life expectancy values of a gear pair system in case of using internal and external gears were carried out theoretically. A comparison of life analysis of involute profile internal and external gear contact, which divides structures such as I said, planetary on harmonical gear systems compared to two external gear contacts was carried out. In the study, tooth root safety and flank safety values were calculated, as I said. KISSOT program is used. This is the modular calculation program for the design optimization and verification of machine elements according to the international standards. It was used the ISO standard at gear calculations. Following equations were used in the program and the study. In the equation, T is the tangential force, B is the tooth width, and M is the module value. The other values, the other constants are factors, such as YF, YS, Y beta, key A, for example, application factor, and the other factors. The limit value of tooth root stress should be preferably be derived from material test using gears. And minimal root safety values can be determined as follow. Minimal flank safety values can be determined as follow too. In the equations of the flank safety values, sigma H is the axial hair stress, and the other variables are some constants or factors. Sigma H limit is the fatigue strength of Hertzian pressure, and the factors is given here, the lubrication speed, surface roughness, and etc. At the end of the relation used to calculate the critical minimum flank safety value is given in equation 1.6. In the study, in order to compare internal and external gear contact in the program, KISSOF program, only internal and external gear contact was created by keeping the number of teeth, profile shifting values, and all gear modifications equal. Information about the selected gears is given in table 1. Selected gear materials is given in here, and the properties of materials are given in table 2. Selected design parameters is given in table 3. Root and flank safety values are given in the results and discussion sections. Also, fatigue calculations was carried out according to the root stress values calculated within the scope in the KISSOF program. Required minimum safety values according to ISO standard is given in table 4. Being able to accurately predict gear failure is an important element of achieving a reliable lightweight gearbox. Among various gear failures, tooth rod bending fatigue is considered the most dangerous, as it means the entire gearbox stops working in this case. In order to characterize a gear for this phenomenon, stress values reaching 3-log or 6-log cycle numbers are generally taken as a basis as the Andrews limit. Figure 1 shows the typical dimensionless ascent curve for gear materials. In the study, 3-log cycle was defined as an endurance limit of the material according to ISO standard. And in this curve, logarithmic life values were identified. Usage equation is given in 2.1. In the equation, sigma A refers to the fatigue endurance, and sigma I dot refers to the tooth bending stress of the gear. Tooth bending stress calculation, as I said, ISO standards is given in 2.2 equation. Infinite life strength for tooth root stress was taken from table 2. Here is the table 2. And tooth bending stress of the gear is taken from KISSOF calculation. The program obtains all factors and data from standards. This allows all account data to be included and the calculation to be made in a comprehensive and detailed manner. Here is the results and discussion. Route safety and flank safety values before the study were given in table 5. Concerning the minimum safety coefficient values of the external pinion gear in the internal gear systems, it has been observed that it's an unsafe level in terms of heart stress. However, safe values were obtained in the internal gear systems. In addition, it's seen that the pressure angle and profile shifting ratios have a significant impact on the safety coefficients. Concerning the tooth bottom safety values or root safety values, the gears of both designs are at safe level. When the power transmitted and all other factors occur, the difference in safety coefficients is remarkable. It's clear that this will also affect gear life. And here is the results of the fatigue calculation. In order to perform the minimum life calculation safely, the limited life region was taken as the basis, and it was assumed that slope in this region contained in the long life region. Here is the figure 1. Sorry about that. Fatigue calculation results is given in table 6. When two throat bending fatigue values are examined, it was observed that there was a decrease in pinion gear in internal gear contact compared to the external gear contact. Besides of this, increase of the value in the gear is also noticeable. It's seen that the pressure angle and profile shifting ratios affect the safety coefficients, and whereas the logarithmic life varies significantly. These values also affect contact ratios. In each gear design, the significant effects of the mentioned values on life and safety factors should be taken into consideration. And here is the conclusions. As a result of the study, it was seen that internal gear contact significantly reduces heart contact stresses, both pinion and gears. In addition, it has been observed that internal gear contacts reduce tooth root stresses in the gear section. In the pinion, no significant decrease in tooth root stress was observed at the internal gear contact. This advantage in the pinion can be eliminated with the multi-planet structure. In these disadvantages in the pinion can be eliminated with the multi-planet structure in planetary systems. Additionally, in harmonic systems, the stress on the pinion can be reduced by enlarging the pinion. It has also been determined that tooth root and surface pressure stress directly depend on the pressure angle and profile shifting ratios. Besides of this, the small space occupied by internal gears reduces the casting cost, for example, of the gear mechanism body. However, having a compact system requires extra attention to lubrication. In this study, ordinary gear contact was taken into consideration. However, internal gears are great importance, not only in ordinary gear contact, but especially in planetary reducer systems and harmonic systems. Concerning the advantages of these systems, it's clear that more intensive research should be done on internal gear systems, and the number of manufacturing of these systems should be increasing. Thank you for listening. My presentation is over. Thank you for your time. Here is the references of study. Thank you. Could you hear me? If you have any questions, I can answer. Could you hear me?
I have a question, a very small one.
Okay.
Talking about gears, so commonly speaking, what are the best way of when we
Hello.
have failure, like you shared an image there when we have failure, which
Mhm.
kind of procedure we use to fix failures? Like we have very important gears, very expensive, and then we want to fix it. Can a gear be like fixed, or we have to create from scratch? Because I've never heard about any technique about fixing a gear.
Unfortunately, many times we cannot fix the gear mechanisms. We change the gear and also we change the bearings or shafts. But unfortunately, we have to change the gear mechanisms. There's no repair techniques about the gears, unfortunately.
Don't you think that it may be a subject of study, ways of fixing gears? Could it be interesting?
Yes, it could be interesting. It's a different perspective, and I am thinking. I will thinking about it. Thank you very much.
Thank you, sir.
Thank you for your presentation.
Thank you very much.
My internet connection is not good, but it's okay.
Thank you
Please,
for the time.
everyone, all of you, turn on your camera for the Congress picture, please, everyone. Yes. Okay. Thank you. Thank you, everyone. I think that's enough. Okay.
Thank you very much.
The session is over. We have a break. Thank you, all of you.
Thank you.
All of them are very good
Thank
presentations.
you. Thank you.
Nice to be in here. Thank you.
I'm very happy to see you.
Thank you
I am
very
too.
much. Have a
Have a
good
nice
time.
day.
Thank
Have a
you
nice
very much.
day.
Have a nice day.
Faruk Hocam, sonuna geldiniz.
Evet ya, ben bir sonraki sunum için aslında devam ettiğini bilmiyordum doğrusu.
Yok, bir 15 dakikası var hocam. Nasılsınız hocam, iyi misiniz?
Çok şükür ya, idare ediyoruz hocam. Sen nasılsın? Ne var ne
İyiyim
yok?
hocam, teşekkür ederim. Çalışmaya devam. Biz bıraktığınız gibiyiz. Benim
Evet
içeriye
canım.
geçmem lazım. Biraz
Tamam,
burası hızlı hareketli. Görüşürüz hocam.
tamam.
Sure.